Hi, my name is Jamie de Jong and I created this video differentiating cosine of x for the course Math 135 at the University of Toronto. The goal is to differentiate cosine of x and similar functions, and we're going to do that using first principles because we don't have already any knowledge of how to differentiate cosine. So we have a function cosine of x, and the question is, what is its first derivative? And if we apply the definition of the derivative, we have the limit as h goes to 0 of cosine x plus h minus cosine of x divided by h. Now cosine of x plus h, we can apply the angle sum formula to that. And we get cosine of x cosine of h minus sine of x sine of h Now you'll see we have two terms that involve the cosine of x, so we can group these together. So that gives us cosine x times cosine h minus 1 divided by h. And our remaining term is sine x sine h divided by h. Now cosine of x and sine of x, they don't involve h's, so we can pull them outside the limit. And we know that the limit of a sum is the sum of the limits. So we obtain cosine of x times the limit as h goes to 0 of cosine of h minus 1 over h minus sine of x times the limit as h goes to 0 of sine of h of h. Now, this limit, we hopefully know well, goes to 1. The question is, what happens with the limit as h goes to 0 of cosine of h minus 1 over h? And that's probably not one that you've necessarily seen before. So what can we do with this? Well, if we just directly tried to plug in h equals 0, we would get 1 minus 1 divided by 0. So this would be 0 over 0. So that's not going to work. And given that we have cosine minus 1, one thing we could do is multiply by cosine plus 1 on both the numerator and the denominator. So let's try that and see where we get. Okay, so once we do that, we can expand the numerator. Cosine minus 1 times cosine plus 1 will give us cosine squared of h minus 1. And cosine squared minus 1, that is a trig identity that hopefully you're familiar with. it gives us negative sine squared of h. So how does this help? Well, it looks like we've been doing a whole lot of rearranging. What does this actually achieve? Well, we can now split this into two fractions. You'll notice, we'll pull the negative sign out the front. You'll notice we have a sine h in the numerator and an h in the denominator. So we can take the limit of sine of h over h. And what we're left with is sine of h over cosine h plus 1. So, once again, this goes to 1. We're familiar with that limit. What happens as h goes to 0 with sine h over cos h plus 1? Well, sine of h goes to 0. And cosine goes to 1, so we get 0 over 2. So overall, this goes to 0. And that means that that entire term goes to 0 if one of the factors goes to 0. And we're left with negative sine of x. So that means the derivative of cosine x, using first principles, we've determined it to be negative sine of x. So I'm going to leave you with a few exercises. The first is just applying what we just learnt to find the derivative of e to the power x cosine x. So now that you know how to differentiate cosine, you can use the product rule to compute that derivative. The second task is to see what pattern emerges when you do this and find the 2020th derivative of e to the power x cosine of x. And finally, I'd like you to try and find the derivative of sec of x using first principles. So we know that sec is 1 over cosine, but I would like to actually do it directly rather than just writing it in terms of cosine. So using first principles and following a similar method to what we just did here to differentiate cosine. If you have any questions, feel free to come and talk to me in my office hours or to ask questions on Piazza. Thank you.